Good afternoon, everybody. We once again welcome you to yet another edition under the Storage and Handling Knowledge series, which is on right maintenance practices for material handling equipment. Before I invite the esteemed speaker for today and set the context for today's discussion, let me briefly revisit the core purpose of creating this platform. So as we have been always saying that this platform is created just to share pure knowledge that we have gathered over decades of our experience in the intralogistics domain, whether it is material handling, racking, or automation solutions. There is a lot of fine nuances that we have gathered, which add a lot of value in anybody's day-to-day operations. And we have taken this responsibility to share this knowledge in various sort of small blocks for you to easily absorb and implement in your day-to-day work. This is our 15th session. We started way back in May 2020, and month after month, we have covered various topics, whether it is different types of material handling equipment, different types of forklifts, what are the safety practices. We also had a panel discussion on batteries and chargers. We have invited guests on this platform. So basically, over a period of more than 1 year, we have been able to make a very thriving community who has been interacting with us, engaging with us on various topics in this space. And that gives us a lot of confidence in carrying this initiative forward. Now, talking about today's topic, I think it cannot have come at a better time when the economy is coming back to some normalcy. We are seeing a lot of traction in the market. The projections are quite positive. So at this time, at any operation, if you're able to talk about how to further optimize your operational cost, I think this will just add to whatever we are doing in our day-to-day operations. Yes, there is a lot of investment happening, but at the same time, if you are able to optimize that investment in the best way, that is where we will be able to get our bottom line up. And what better than the right maintenance practices to sort of discuss and talk about for us to get that purpose met. Now, when we talk about maintenance practices, it's a very wide topic and it varies from equipment to equipment, the type of equipment, the category of equipment. But today, what we are going to talk about is in a very general, holistic way, in a very simple, easy to understand language, which anybody and everybody can take something back after this session. Like when we talk about maintenance practice, what are the total cost of ownership? How do you arrive at that? What is it that is the right time to actually either continue the equipment in operation or you should look at refreshing your fleet? So those sort of nuances is something that will be discussed in today's session. With that, let me introduce you to today's speaker. We are very, very privileged to have with us Mr. Manish Singh, who is going to take us through this very interesting topic. Manish has been with Godrej for more than 20 years now, having a very rich experience in almost all front-end functions. Like he started from sales, he handled branches, he looked after key accounts. So key account management is one of the forte that he has, and he has very deep knowledge of the service aspect of the entire range of material handling equipment that is available in the industry. Like he has been responsible for coming up with very innovative products and services, and we could not have got a better person to take us through this important and interesting topic. Now, before I hand over the forum to Manish for him to take us through this topic, I would request a couple of things. One, please post your questions in the chat box during the course of the session, and please, don't put the questions anonymously. It doesn't allow us to get back to you in case we are not able to cover all the questions. So please write your name and company name while posting your question. That is one request. And second, once the session is over, of course, this request I would make once again at the end of the session. There will be a feedback link. We would request you to please share your valuable feedback in terms of how did you like the session, what we could do better, and you can also indicate what topics would you want us to cover in forthcoming sessions. So these are the two requests that I have. With that, I would request Mr. Manish Singh to take over from here and let us have a very, very fruitful and insightful discussion. Thank you very much. Over to you, Manish.
Thanks, Abhishek, and good afternoon to all the people who have joined on this platform for this session. And I thank you all for that. Abhishek has given quite an elaborative introduction about me. I will just add a few key points before starting on the topic what we have today. So as Abhishek has said, I'm with Godrej from last 20 plus years and handled different portfolios. And from last 6 years, I'm based at Mumbai head office, where I'm looking after the aftermarket business. In last 3 years, mostly I have focused or worked on digital enablers to augment revenue and enhance customer satisfaction and experience. So those are the things. Besides that, my educational background, I am an engineer. I've done my engineering from NIT Durgapur and completed my executive MBA from IIM Calcutta. This is briefly about me. My hobbies are sports, traveling, and long distance running. So this is brief about me. Now let us come to the topic, which is for today's discussion, right maintenance practices for metal learning equipment. So these whatever maintenance practices we are going to discuss today, they are applicable to all industrial equipments. But I will try to cover them with the perspective of metal learning equipment. We will try to cover these practices at a macro level without going in the micro detailing of the exact things which are supposed to happen with the equipments. So when we move to our topic, which is right maintenance practice, so it constitutes the three words: what is right, what is maintenance, and what are and the third thing is practices. So I will try to go deeper in each thing. So first, let us discuss about what is right. So any practice or process which is capable of taking you to your desired objective is right. So that is the definition which we are trying to create for the right. What is right? So if we want to identify what is right, what will be the barometer to decide that? So let us think we want to achieve an objective. So we should have a clarity about what is the objective of these maintenance practices and on what basis we will decide whether it is right or not. So traditionally people used to think that maintenance practices are basically derived to reduce maintenance cost. But now the horizon has increased. It is not only about the maintenance cost. The major thing what people are discussing today, how can you reduce or optimize the total cost of ownership? So the horizon has got enhanced, where we are talking about, it is not about maintenance cost, it is all about cost of ownership. So if we are able to optimize our total cost of ownership of any machinery, then we can claim that we are following the right maintenance practices. So if we are clear about this objective, what we have, we will try to understand how this total cost of ownership is computed. So basically, if you want to optimize a total cost of ownership, you have to ensure, because it is mostly dependent on the two factors, you have to work in two zones, two right zones. So which are those zones? So first is a zone which is related to throughput. Throughput, it is a bathtub curve. So if your throughput requirement from the equipment is less a particular threshold value, then your maintenance cost or operational cost for that equipment will all, you cannot optimize it, and it will go beyond your permissible levels. Similar way, if your throughput requirement of the equipment, which is higher than the throughput capacity of that equipment, and you try to sweat the equipment more than it can take, then what will happen? Your maintenance cost will go beyond that zone where you can optimize your cost. So we have to have a very good clarity when we are using the equipment, whether we are utilizing them in that band of throughput for which those equipments are designed. So this is the first this thing, and the second is at what age you are using the equipment. So accordingly, you have to identify how I can optimize, whether I am using the equipment in a right age zone to optimize the maintenance cost of my equipment. So basically, if you see maintenance cost, though you are seeing two curves here. One is prevention cost and another is repair cost. Though this y-axis will be different. So just for the clarity, we are seeing the shapes because prevention cost will be as considerably less than the repair cost in terms of value. But what is optimization? You have to see that how you can find a right balance between a prevention cost and repair cost, and if you are having the right age bracket where this balance is favorable to you, and then through that intelligence maintenance, instead of doing a reactive or a proactive maintenance, how you can find that fine balance which will help you in optimizing the total cost of ownership. So basically, are able to optimize these two curves and ensure that we are operating within the right zones, we will be able to optimize the total cost of ownership. I hope up till now we have the understanding that what is our objective. Our objective is to optimize the total cost of ownership. Total cost of, for optimizing it, we have to ensure we are operating in the right zones in terms of age and in terms of throughput. Now, when we are clear that this is our objective and we want to optimize our total cost of ownership through the right maintenance practices, then let us have a deeper understanding how this total cost of ownership is calculated and what are the different elements it has. So if you see, the total cost of ownership is there is some cost of purchase, then there will be some amount of money which we will be spending for running that machine, and the last part is the cost of disposal. So if you see, this cost of disposal may be positive or negative. For a metal handling equipment, it is always positive. So normally, if you sell old equipment, you will always get some amount of money. But there are some hazardous things where this cost of disposal may be negative. So the summation of these three values will give you the total cost of ownership. Now, if we understand this, that this is the total cost of ownership, and now we try to understand what are the normal breakup of the cost which customers or anybody will spend on a metal handling equipment. So if we see a lifetime of a metal handling equipment, normally 14% constitutes the capital cost or the purchase cost, and which includes purchase and the finance cost of a equipment. 41% we spend on energy, or you can say fuel. So for a counterbalance equipment, it will be the cost of the fuel, diesel, which will be there. And in terms of battery operated equipment, that will be the cost of the electricity which you will be consuming for charging your batteries. So that element is 41%. The 17% cost which normally people spend is on the operators who are going to drive your machines. And finally, the last bracket is 28%, which is the cost of maintenance plus technical support. So basically, cost of maintenance means cost of spare parts plus the service support, what you are going to get, and the summation of that for a lifetime. So if the equipment lifetime is, let us assume it is 10 years, the amount of money which you are going to spend in the from cradle to grave of that equipment, 28% of that will be the cost of service. Now, if we have this understanding of the cost elements, then we have to understand, okay, what will be the impact these right maintenance practices can have on my total cost of ownership. So on the service cost, which is 28% of the total cost which you are going to spend on a lifetime of the equipment, you have a direct impact of this right maintenance practice, and you also have an indirect impact on 58%, which is energy and the operator cost. Because if you are following the right maintenance practices, you have the possibility to optimize your energy consumption. You can ensure that by having the right maintenance practices, you can improve the morale of your operators. You can reduce the attrition in your operations and ensure that you are able to optimize the operation cost too. So now we have understood this total, whatever total cost of ownership is there on the lifetime of the equipment. This right maintenance practices will have an impact, direct impact on the 28% of the cost, and have an indirect correlation with the 58% of the cost. So it is very important that, because it has a huge impact on whatever the amount of money anybody is going to spend on a lifetime of the equipment. So Now, up till now, we have understood that what is our objective, which is to achieve or optimize the cost of ownership. We have seen what are the elements of the cost of total cost of ownership and how these right maintenance practices can impact on this cost of ownership. So now let us see what is right. When we have all this basic understanding, how we will decide what is right. So if we come, there is no perfect practice, maintenance practice in this world. It has to be tailored as per the requirement. So basically, so there is no thumb rule, there is no standardized maintenance practice which can be replicated at all the places for all the equipment, but it has to be derived. And when you have to derive a right maintenance practice, you have to understand what is, it is a function of what elements. So what are the variables which will decide that whether we are able to create a right maintenance framework for our organization or not. So it is basically a function of three elements. One is, first is very important, which is throughput. So what is your throughput requirement? Then the second part is when you are identifying your throughput requirement. Let us assume you say this many average working hours my equipment are supposed to be used, and this is the amount of material it has to move from one place to another. But we also have to consider whether this throughput or the requirements are uniformly distributed, or there are some spikes or seasonality where, like, there are organizations where the throughput requirement suddenly peaks at the end of the month, or there are certain seasons where they have a spike requirement of a throughput. Now, for achieving that, you have to derive or you have to customize your maintenance practices, which should suit your these spikes requirement, because you have to prepare for that. So once we are sure, okay, yes, we are having the understanding of the throughput, but we also need to have the understanding of the variations in the throughput and the spikes and this thing. And that will help us in designing the right maintenance practice. So this is the first variable which we have to consider before deciding what is the right maintenance practice for my equipment or my organization. The second aspect is, which we have to take into the consideration, is working environment. In which work environment my equipments are expected to be used. This work environment is whether it, because every organization or every customer is unique, and it has its own unique requirements and limitations. Like people, there are equipments which are being used in a dusty environment. There are places where the humidities levels are very high. There are places where the equipments are used in a very high temperature zones. So all these things creates a working environment around the equipment, and we need to have the understanding of the impact this environment will make on the equipment, which should help me in deciding that impact according how I'm going to neutralize that impact and what kind of precautions or the maintenance practices I'm going to create for my organization, which will help me in optimizing the cost of ownership. So the second most important and thing which variable which will decide in identifying the right maintenance practice will be work environment. And the third other important aspect is, what is the criticality index of the equipment? Now, these equipments are used for different applications, different purposes. Some of the equipments are used in your raw material stores, your finished goods stores, warehouses, and they are supposed to load or unload the material. There are certain equipments, material handling equipments, which are used to load your manufacturing machines. So they at that place, your material handling equipment works like your assembly or a production chain. So until and unless that equipment is able to feed your production machinery, you will not be able to take out any output out. You will not be able to create any production, make any production. So for that, the criticality index of that equipment is very high, or the criticality index can also depend whether you have an alternate, whether the task which this equipment is supposed to be done can be staggered or postponed, or it is must, because if the equipment is working as a transporting a semi finished material from one workstation to the another workstation, if it doesn't happen in a particular time frame, then your whole production may get hampered. Sometimes even the furnace has to get stopped, and it results in a huge losses for a customer if they are not able to manage the criticality of that equipment, understand the criticality of that equipment, and maintain the right kind of maintenance framework to meet those requirements, production requirements. So these are the key three variables which needs to be considered before you tailor your maintenance practices. So now when we have understood this, okay, how we can derive what is right for my equipment or for my organization, we can move forward that what are the other factors which will impact these right maintenance practices. So based on these variables of working environment and throughput, the maintenance practices will vary from the customer to customer, because for a same throughput requirement, it also the customer, the behavior of the organization which has to be considered. So what is the type of culture that organization have? What is the type of practices this organization is following? That also impact the maintenance practices. So different customers will behave differently. A logistic company, for a logistic company, material handling equipment may become a life and death issue for them, because their whole operations are only dependent on that equipment. And if that equipment is not operational, their production or their whole operations will stop. For some other places where they have flexibility, they can stagger their dispatches, or they can do that, there may be the criticality of that equipment is not very high for that customer. So this maintenance practices will vary organization to organization, customer to customer, and industry to industry. The second point which we have to consider before deciding what is the right, we have to understand the product, because product is also very important. Before deciding the right maintenance practice, do we have the right understanding which product I'm going to use for this application, and what is the maintenance requirement, specific maintenance requirement of that product? What is its build? So once we will have this understanding, we can decide what is the right maintenance practice I'm going to follow. The third part is the locations and locale. So geographical location of an industry also makes a difference in deciding the maintenance practice. Like where your factory is situated, what is the distance from any support system or the ecosystem around your industry, because some of the industries are at a very remote place, so they may have to tweak their maintenance practices to overcome the challenges of working in a remote environment, because their lead times will vary, their support systems will vary, their logistic time period will also vary. So all those factors needs to be factored in before arriving on what is right for me. And we have, I have already discussed that criticality index of the equipment has to be evaluated or identified. So if that equipment is not in operational condition, what kind of impact I will have on my production, impact on safety of my man and machinery, what kind of MTBF I can expect on this category of equipment, what is the lead time for if I have to get some part, and what is the probability of failure. So accordingly, after considering all these factors, you have to identify and calculate the criticality index of the equipment, and that will decide what kind of right maintenance practice you have to follow. So if I have to summarize all these things, the operational expectations and the requirement of the organization, the throughput, your criticality index, your uh, working environment, we can summarize it as an application. So we say before identifying or selecting the right product for your this thing, we should have a deeper understanding of the application. So application is nothing. Application is a summarization of all these points where you identify what will be my throughput requirement, what kind of working environment I have to do, what will be my expectations or requirement and challenges in working at particular place, and then accordingly you decide what is the right product and right maintenance practice for your application or for your organization. So these are the factors which needs to be considered before finalizing what is right for my product or my organization. So if I summarize on what factors we will identify or create the right maintenance practice. First thing is very clear. There is no thumb rule. There is no perfect maintenance practice. It has to be derived. When you are trying to derive the right maintenance practice, you have to understand what is the requirement, expectations, what will be the age of the equipment I have, in what working environment I am working, what is the application, what is the criticality, and what is the environment I am in. If I am working in a coastal environment where the humidity is going to be high, then I have to understand, okay, how it is going to impact the various components of my equipment. Or if I am working in a special temperature zones like cold storage, where the equipments are used for -20 or -30 degrees centigrades, what kind of impact they will have on the components, and how the failure patterns will change, and to compensate that, what kind of right maintenance practices I should follow, which will help me in optimizing the total cost of ownership and also meeting the requirement of the throughput requirement of my organization. So this is all about what is right. Once we have the understanding how we can derive a right maintenance practice, let us talk about what is maintenance and what are the different kind of maintenances performed for the repairs of any machine. So basically, broadly, if you say, There are three broad type of maintenances which are performed on each machinery or each equipment. So one is the breakdown maintenance. Whenever any, it is basically a reactive maintenance. Wherever any problem crops up and you have to identify the problem and you have to solve that problem. It is a breakdown maintenance. It is basically reactive. You have to prepare for that kind of eventuality, and how you are going to complete that maintenance activity in a shortest possible time will decide what kind of turnaround time you can expect from that thing. We will go deeper and understand the pros and cons of each kind of maintenance, but breakdown maintenance is quite understandable. It is basically, it is a reactive maintenance. Whenever any failure has happened, how you are going to set it right in the shortest possible time. That is the breakdown maintenance. The second is periodic maintenance. So periodic maintenance is the regular and routine maintenance of the equipment which needs to be performed at a particular time interval and at a predefined set of activities needs to be done on a equipment. It is basically done to safeguard your costly sub-assemblies and ensure that to enhance the life of those sub-assemblies, you need to do this periodic maintenance at a particular schedule which is given or derived. And sometimes when you are having a good understanding of the environment, you may have to modify those periodic maintenance frequencies to cater to the specific working environment challenges. So periodic maintenance is basically is defined by any OEM, but if it has to be tweaked, you have to have a good understanding of the working environment and what kind of impact it is going to have on my machine and what kind of tweaking is needed, which will help me in optimizing the cost of it. So this is the periodic maintenance. And the last thing is predictive maintenance. So predictive maintenance is where either you use a very highly skilled or experienced person to predict failures, or you can use data. Nowadays, people mostly use data because it is possible to get that data from the machines. You can monitor the certain vital parameters of the machines through various devices. You can collect that data, and after having that knowledge and understanding, okay, if the variations are coming in particular parameter of a machine, how it is going to impact the operation of a particular sub-assembly and how you can predict the failures. So basically, predictive maintenance is going to help you in avoiding any unplanned breakdowns. So if you can predict failures, you can avoid unplanned breakdowns or the sudden shocks which you get when suddenly when the equipment requirement is at its peak and suddenly you find there is some problem with your machine and you are not able to uh, fulfill the task which you have on your hand. So to avoid such kind of situations or scenarios, people have to uh, collect information, data, they have to monitor their equipments, and that will help them in uh, doing the predicting the failures and doing the maintenance on a proactive manner instead of reactive, which is normally done when the equipment has some failure and you have to resolve that issue. So these are the three types of maintenance, but all these three types of maintenances are performed on each machine. You can you can change the mix, but all the three types of maintenances has to be performed on the machine to optimize the cost of ownership. So the mix can be changed, the frequency or the dependence on a particular type of maintenance can be changed, but you should have the capability to perform all these three type of maintenances. Then only you will be able to achieve your goal of optimizing the cost of ownership. So let us go deeper. What is breakdown maintenance? Breakdown maintenance is, as I've said, it is a default reactive maintenance practice, which is, it is like uh, if there is a component which is not very critical, it can be replaced in a shortest possible time. The availability of that components are easily available. You don't need very special kind of skill to repair that thing. Then normally people say, instead of doing predictive maintenance or prematurely removing that component before failure, I will wait for the failure, and I can do that because I have the right skill, I have the right component, it is easily. So it is like if you try to make an analogy, normally like us, we normally see we are not very afraid of a normal cold or a flu, because we know that even if it is there, I can get the medicines at a very nominal cost. I can get the general physician who can consult and provide the required guidance, and I can be up and running again in a very small possible time. So we are not worried about those kind of ailments. But for serious ailments where the cost of maintenance or repairs is very high, then you have to invest on periodic checks, and how you can predict failure, how you can gauge if any abnormality is there at the initial stage, which should help you in reducing the cost and all that thing. So breakdown maintenance are mostly done uh, when any small component like bulbs or a fan belt or something like that, non-critical components, which is a very low value item, and it can be replaced in a very short possible time. So people do that kind of maintenance. And the only thing which they have to consider, whether they have the right skill to repair the machine. So what they have to do, assess the skill uh, they have in their organization, or if they are not having, how fast they can source it from outside, whether those skills are easily available outside your organization. Then sometimes whenever you are doing the breakdown maintenance, whether your people are skilled enough who can take the repair versus replace decision. So if any component has failed, a maintenance guy has to make a decision whether he wants to repair that component or he wants to replace that component. Because if he is not making the right decision, your failure rate will increase. And you have to have a fine balance. If you are replacing all the time, then your cost of maintenance will increase. So that you have to find that right balance between whether you have to repair or replace, and that requires skill. So if you are doing breakdown maintenance, you have to assess whether I have the required skill set who can make those repair versus replace decisions, and what will be my turnaround time, means how fast I can bring back the equipment in operational condition. So if you can do that, and if the cost of that component is not very high, it is not very critical, then you can go ahead and take a decision. Yes, I have the right skill set, I have the right component, and I will wait for that component to fail, and then only I will replace. So those are the decisions which are taken by the maintenance managers or the operational managers. Now, for the pro and cons of breakdown maintenance, basically, if you are overly dependent on a breakdown maintenance and you allow all the components to fail, it may result in a cascading effect, and multiple components may fail simultaneously. And that is a bad situation for any maintenance person, because if multiple components have failed, it is very difficult first to troubleshoot and identify what has gone wrong in the machine. The second part is whenever you are uh, doing that maintenance, whether you are only seeing the symptom or you are able to identify the root cause of that failure. So it is good where the failed components are low cost, it can be replaced, downtime is less, but it is not very desirable where you are not having the required skill set to take repair versus replace decisions, or you have the capability of identifying the root cause. Otherwise, you will always keep on resolving the symptoms, and it may result in repeated failure. And that is not, and it may lead to a failure of a high cost subassembly also. So those are the pitfalls, or you can say disadvantages of doing breakdown maintenance. So it is normally, it should be avoided as far as possible until unless it is a very low cost component. The second part is there are organizations who take plant breakdowns. Why they take plant breakdowns? Because for them, unplanned breakdowns are are not desirable, because of the criticality index of that equipment is very high, and they cannot afford, when their production is at peak, the equipment is not functioning. So normally, if you see, a lot of industries take plant breakdowns. So they take shutdown where they dismantle the machine, they open, they identify what needs to be replaced. They should have the full-fledged maintenance setup to do that, or they outsource or source this capability from some external agency, and then do the maintenance. This maintenance, whenever you are doing the plant breakdown maintenance, it is good for certain organizations who can afford to take plant shutdowns. But there are some other operations or the industries where you cannot, which are continuous processing plants, and you cannot afford to take maintenance breakdowns, where your criticality of that equipment will go further few notch high, and you have to decide how you can avoid unplanned breakdowns, or how you can ensure that your turnaround time of maintenance is low. So key aspects for a breakdown maintenance, you have to see whether we have the right skill who can take that repair versus replace decisions. For high cost components, the breakdown maintenance should be avoided at all cost. The third part is whether it is possible to take planned breakdown maintenance, and you can complete the maintenance activity in one go, and ensure that you are not compromising on the reliability factor of your machine. So this is about breakdown maintenance. Now we go with the periodic maintenance. Periodic maintenance are like our simple low cost things which needs discipline and will to do. Like we all know, okay, for a healthy life, what we need to exercise regularly. We need to have the right eating habits. Not very costly. it is possible, easy. It does not require a very high skill for doing that, but it requires a discipline and the will. The other thing is, so normally people follow the routine preventive maintenance schedules, and they are supposed to complete that activity, whatever is been guided and or designed by them or crafted for themselves. The other challenge is the in the periodic maintenance is the teamwork. So if you have identified that this is the frequency at which you are going to do the preventive maintenance, and uh, uh, equipment has to be reported for periodic maintenance at that time, you need the cooperation and support from your operational people, because the major challenge people face is that because this maintenance has to be done when the equipment is in operational condition, the operational teams are not able to release the equipment because of their work pressures. They are not able to release the equipment for the routine preventive maintenance. So that cooperation or alignment is needed between both the teams, where they understand each other's limitations and the challenges and identify the right way which will help them in performing the periodic maintenance in a timely manner without missing them. And because it is not a very costly thing, but ultimately if it is not performed on time, it can have a serious repercussions. So it is most important thing for a periodic maintenance is the discipline, the will, and the teamwork which is needed. Now, if you see the advantage and disadvantage, these are very simple, so I will not spend much time on that. It requires, I have covered various things. It is initial cost is low. It is not very high cost investment. It requires mostly the discipline. Sometimes people may think that even if before the failure, why we are replacing certain consumables or filters when it still it can be used. So because we are trying to de-skill the things, and we don't want people to make those decisions of when to replace, what to replace. They are supposed to follow a particular schedule which is identified or created by the organization or the OEM for that product, and they say please don't use your brains. This is the schedule which has been created and you are supposed to follow that schedule. And mostly it is not very difficult. It does not require very high skill, but it requires that discipline and will to do. So after periodic maintenance, let us move to the predictive maintenance. Predictive maintenance, again, if we say same analogy like ourselves, how we are maintaining our bodies. So we up till now, what we were doing, we were taking some health checks on a yearly basis where we are monitoring certain vital parameters. Doctors used to we carry out that tests, and then some expert person will see that and identify what are the symptoms or the patterns he can see. And accordingly, he decides what needs to be done or what precautions needs to be taken to avoid any major failures in future. So this was the basic understanding, and this was used to be done. And it requires the what was the most important thing at that time? That person who has the knowledge and understanding after seeing that report, who can understand and predict correctly that which component or which subassembly is expected to fail, what is the cause of it, and what kind of uh, repairs needs to be performed now to enhance the life or increase the life of that subassembly. Uh, but nowadays, what has happened with the development in technology and all those things, we can get these data on a real time. So now we can have some sort of a watch or something which is monitoring our BP or temperature or other vital parameters on a regular frequency. The same way you can install some sort of a sensors in your machine which can continuously collect information of certain vital parameters like temperature, pressure, current, voltage, and accordingly those variations in these vital parameters can give you that understanding or knowledge, okay, what is expected to fail and how it can be uh, you can say uh, repaired or can be rectified in a proactive manner before the damage has already happened for to that component. So it is a good thing. It has to be done. And predictive maintenance is very important if you want to achieve higher uptime of the machines, because it helps you in avoiding any unplanned breakdowns or major breakdowns. So you can prepare yourself or your organization for that kind of eventuality and take proactive measures. You can plan your activities, so you can source the item which is expected to fail earlier, so that whenever it will it is going to fail, or you can, if you want to replace it proactively, you can do that. And it uh, increases the asset uptime up to 30%. So if you are having uptime of a machine of, let us say, 80-85%, you can increase it by 30%. So you can, predictive maintenance is mandatory if you want to achieve anywhere between more than 90% or 95% uptime of a machine, because then only you can uh, uh, complete all the support activities which are needed. So for the either to do that repairs in a proactive manner, or ensure that whenever that maintenance is needed, you can do in a shortest possible turnaround time. So this is the thing. This is the beauty of the predictive maintenance. It requires some sort of investment in terms of getting those or collating or collecting those vital parameters or information from the machine at a particular frequency. With the advent of technologies, this you can collect or collect this data at a very small frequency intervals also, and it will help you and you require that skill set. So now with the machine learning, there are complex algorithms are written which can help you in taking those decisions, but if they are not available, you need to have that special skill and experience to take measures which are needed to be uh, taken at that time to avoid breakdowns in future. So it basically helps you in maximizing your uptime. So predictive maintenance is nothing but help you in maximizing your uptime. So now when we have this understanding of the different kind of maintenances which are being performed on a machine, we have reached to a level of understanding. So how we can identify what is right for my machine. We have the understanding of the objective. We know where we want to reach. What are the factors I have to consider to design by the right maintenance practice? Then what are the different kind of maintenances I'm supposed to perform? What will be the mix I have to keep to optimize the cost of ownership? Then so we are clear about what has to be done. Now the thing is how it has to be done. If once you are clear, you have the clarity what has to be done, then people decide their people evaluate their strengths and their priorities or organizational priorities, and create a framework that how these maintenance practices, whatever they have derived or designed for their operations, has to be performed. So there are organizations who take the decision that they will execute themselves. and they have the right maintenance setup, and they source the knowledge or the uh, resource on need basis from outside. And there are organizations who would go with the asset light model. They don't have resources, such high resources, and they outsource the activities to somebody. So accordingly, there are different kind of maintenance plans which are crafted or designed to meet the various maintenance need of the customers, whether it is related to only technical assistance, preventive maintenance, or a full service contract where people want to offload all the activities to somebody and who is responsible or who is the subject matter expert in terms of performing those activities. So after doing that, this is where every organization decides how I'm going to perform those maintenance activities. Now, once we have achieved or reached to an understanding how it has to be done in my organization, then we try to focus on how they are going to get performed. So then the practice will come in the picture. So once we are having the clarity, what is right for my organization, what kind of maintenance I am going to do, what kind of mix I will have, what I have evaluated by the what kind of skills or resources I am having, what is my maintenance philosophy. I have decided what is I'm going to do in-house and what I am going to do outsource. Then what are the practices has to be followed for execution, whether it has to be done in-house or it has to be done by any external agency. There has to be some practices how I'm going to ensure that whatever I have identified or planned, it is happening, it is getting executed in the right manner. So there the picture, these practices play an important role. So there are execution practices which are followed by the organizations. So mostly they schedule their maintenance activities. Earlier, they used to have a calendar where they were scheduling it. Now, with the IT support which is available, you can schedule the activities on any platform, and that platform is capable of giving you reminders 5 days prior to the or sending you notifications or reminders, alerts that this activity has to be performed or this task has to be completed during this time interval. Please plan your activities, and we need to have that discipline of uh, checks and ensuring that these schedules, whatever we have created for ourselves, we have to adhere to it. So basically, we all it is very simple. It is nothing. It is not a rocket science, but we have to adhere to whatever we have planned to do. The second part is how you are going to monitor the performance. So there are certain certifications, legal certifications are there. You have to get them recertified. Sometimes your operators, sometimes you have to get your machines recertified. And all those things needs to be monitored. There has to be a proper checklist which needs to be maintained, and it needs to be audited at a particular frequency that all. So basically, all these things uh, results in some sort of a dashboards which are monitored by the maintenance guys, and they see and monitor whether my execution is happening in a right manner or not. And once you are having you are adhering to the schedules, you are monitoring it, and you are ensuring that those are performed in a timely manner. The proper records needs to be maintained, and these records help you in understanding the patterns, failure patterns, and deciding corrective actions and preventive actions for future. And this this closed loop activity where we are doing certain activity, monitoring it, creating records, again seeing the pattern, taking correctives, again going back and doing will help us in optimizing the cost of maintenance. So this repeatability of this PDCA cycle has to be done. Then only we can achieve that optimization of the cost of ownership. So this is about the execution practice. Now I will share some of the best practices which are followed by the other organizations, which help them in optimizing the cost of ownership and avoiding failures to their material and the equipment. So these are basically organizations which ensure that they are using the right grade of lubricants. And it is very important that lubricants, the right lubricants are used, because they enhance the life of a particular component. And the another thing which we should be concerned of is how we can ensure that the pilferage of lubricants can be avoided. Because if you allow that to happen, then again the grade of the lubricant will get compromised, and that will result in higher maintenance cost or unplanned breakdowns. The other part is good organizations normally go and they use only genuine spares. And why they use genuine spares? Because they want to be assured about the quality. So like there are multiple bearings are available, there are different grades of material are available, but how I will ensure that I'm using the right grade and right quality of bearing for my machine? So it is very important that we ensure and we get the right genuine parts for this thing, for our machines to work longer, and it will also help them if we are maintaining them well. It will help them in enhancing the life of the machine and getting a higher disposable value when they want to dispose that machine. The third part is in the operation practices. There are devices which are available, like biometric access devices, or a pin based or a card based devices, where you can ensure that unauthorized people are not operating on your machines. And it goes long way. If only the authorized operators are operating your machines, your maintenance cost will come down drastically. Believe me, it creates a lot of impact in terms of the cost of maintenance and the uptime of the machine. For enhancing the safety of their people, they sometimes, because it is a mobile machine, what we are talking about in material handling equipment, machinery, we have to create some sort of a virtual zones, no movement zones, which will ensure that we are all the people who are there in our premises are safe. There are other devices like overloading protection devices are available, which some people use, which ensures that operators cannot make that mistake unknowingly where they are overloading the machine, and it helps them in ensuring that finally their maintenance cost or the machine should not have any unexpected breakdown because of the overloading. Now, because we are in this metal handling equipment where people have to work at a very higher heights of 11 meters, 12 meters, how you can enhance the visibility of your operators, how you can provide him the complete visibility of all the places where he is operating his equipment. The camera systems are helping in identifying or reducing the fatigue to the operator's neck, and it helps them in increasing the productivity and the morale of the operator. There are other productivity enhancement tools are available, which some of the industries use, which helps them in improving the productivity of the machine and the operator, because it allows people to complete the activity in a shorter time period. And there are vehicle monitoring systems available, which helps them in getting the required information or the right information of throughput, usage of the machine, how the operator is using, whether there is any impact happened on the machine or not. So those kind of information is collected and collated, and it helps them in reducing the maintenance cost. So these are few devices which are uh, used as add-ons on the mechanic equipments, which help them in reducing the unexpected failures and optimizing the cost of ownership. And last, after all that thing, when you have optimized the cost of ownership, there will be a tipping point where you have to take a decision that now I have gone out of that zone which I have discussed at the first, where you have to for optimization of cost of ownership, you have to work in a right age zone. So where your equipment has reached to a threshold or a tipping point where you need to consider that time has come where I have to replace it with a new equipment. So different people use different yardsticks to achieve or identify that tipping point. Basically, there is a place where your repair cost uh, goes higher than the capital cost of the equipment, and normally organizations take that uh, point where if the equipment throughput requirements are high and they decide okay, now that stage has reached where they have to think of replacing this equipment with a new one. So I think I have overshooted some 10-15 minutes. Sorry for that. But with that, I have covered whatever I want to convey. Thank you all for patient listening.
Thank, thank you so much, Manish. No problem about overshooting the time because I think this was a very, very important topic, and the way you explained it, I think people would rather appreciate this extra 15 minutes of time because a lot of important aspects were covered in this almost 1 hour 15 minutes of talk that you have given. So there are a lot of questions we have got, and I would ask them one by one. But I think one of the key takeaways that I had from this webinar was when you said that there's no thumb rule for a right maintenance practice, and we really need to define it as per the application, as per the equipment, as per the throughput. So that was really very nicely explained. And then you went on to explain the different types of maintenance. And the last part was really very important, where you spoke about the tipping point, where uh, actually replacing the equipment becomes more commercially more viable decision than to continue operating the equipment and incurring the maintenance cost. So I think it was very well covered. Now taking that as a cue, one of the questions which has come up is that there's always that confusion between warranty practices and maintenance practices. Okay, so what is the OEM's point of view of how should they look at how do they look at warranty and how do they look at maintenance? Is warranty a part of a right maintenance practice? Is one of the first questions.
Good, Abhishek. Very good question. Basically, maintenance practices don't depend upon warranty. Maintenance practices are independent of warranty because warranties are against any manufacturing defect. So warranties does not have any bearing on the maintenance practices. Maintenance practices has to be performed on the base or designed or derived from the base of application, requirement, and all other things. Because warranty is only taking care of your manufacturing defect. If there is any manufacturing defect, it is getting covered under warranty. So I hope I'm able to answer your question.
Right. So the next question which has come in is what is the difference? Now this is a very specific question in maintenance between diesel and battery operated equipment. So in a nutshell, if you could just broadly specify.
So there are a huge difference between a diesel and a battery operated equipment, and I think this time is too short to go in deeper on that part. Mostly, if you see a battery operated equipment, you have to understand that its drivetrain is totally different. So in a battery operated equipment drivetrain, you will have motors, controllers, and the power source as the battery. So you have to identify and decide the required maintenances which needs to be performed on these components. Where in a diesel equipment, the drivetrain is basically your transmission, your engine, and your axles. So the maintenance needs of that drivetrain and this drivetrain is completely different. So and I have to go deeper if we have to go each by each sub-assembly or component. What are the maintenance needs of engine or a transmission or a motor or a controller?
Right. So maybe we can have a separate session on diesel and electrical powered equipment maintenance practices. I think that is something that audience would appreciate. So
Yeah.
the next, yeah. So the next question is when we speak about right maintenance practice to be defined as per application, then there are always certain OEM guidelines of maintaining the equipment. So how do we draw a connection between the two?
So, Abhishek, I will say that OEM guidelines are always the base of the right maintenance practices for that equipment. And that needs to be tweaked as per the application or working environment and all other throughput requirements or the criticality. So the base will be always the OEM guidelines, and then you have to understand your specific local specific requirements or the constraints whatever you have, and then you may have to tweak those OEM guidelines to tailor them as per your requirement. Sometimes you may consult the OEMs and you can do it jointly, or you can, if you have the expertise, you can do it alone also. But the OEM guidelines will always be the base for any right maintenance practice.
Okay. Now the next question is again a very specific question that what kind of maintenance practice is advised for 24 by 7 operations?
I will say 24 by 7 operations. Ultimately, it will result in what kind of throughput you are having and how what kind of design your equipment has been created. So if when we say 24 by 7 requirement, normally there is a misunderstanding. Sometimes people say I have a 24 by 7 requirement. That means the equipment should be available for use for that much time period. But normally the equipment is not going to be used for 24 hours into 7 days continuously. So as per the specific need, you have to identify what kind of cooling period you have to provide, because every machine will need some cooling time. And that has to be provided. So no machine is perfect. Even in our body, we have to have some hours of sleep necessary. Then only we can continue working. So that sometimes temporarily you can use the machine for a particular time period or a particular application, but I think you need to have more detailed understanding of the application when somebody says that I have a 24/7 requirement, and then you can design.
Right. So it boils back to the same point that we have to really understand the application and then customize the maintenance requirement for that particular application.
Right.
Right. So there are two questions which are similar in nature. So I will read both of them together and you can choose to maybe have a common answer for that. So the first question is what kind of data can be obtained from devices to help in equipment maintenance? So that is first question. What kind of data can be obtained from devices to help in equipment maintenance? The second question is related to uh, the role of IoT in the field of maintenance and any device that can be fitted which can monitor the health of the equipment. So both are in a way talking about how does an OEM look at data and where does that data get populated to define the maintenance practices?
Right. So, very good question. Basically, IoT devices can be fitted, but IoT devices cannot provide you the right maintenance or what is the maintenance activity has to be performed. IoT devices are only there to collect data points. And mostly these data points, whatever you are getting from your sensors, are uh, you have to integrate certain information. So different informations are coming. Sometimes your equipment in motion, sometimes equipment is stationary, sometimes you are lifting your forks, and accordingly there are some changes are happening in terms of temperature, pressures, current. So these are the information and the time. So time is one important thing, and on a time scale of one axis of time, you try to plot the other parameter like temperature, pressure, your viscosity, your current, and or torque, and accordingly you decide that where you need to intervene or what correctives you need to take or where it is going beyond the permissible threshold limits, which parameter is going at what time, at what operation it is going beyond a particular threshold limit, and you need some sort of a correctives there. So it cannot answer the question, but it can, okay, what kind of right maintenance practice or what is the health of my equipment? It cannot answer that. IoT device cannot answer that, but it can definitely provide you the necessary information, which if you have the right knowledge and the experience or the algorithm, that will decide or that can help you in identifying what is the right health of my. I
Right.
hope I
Right.
am able to answer them.
I think so, yes. So there are two, three questions which are similar in nature. So let me try to combine them and put it across to you. It is about uh, getting spares from non-OEM sources and getting services from non-OEM personnel. Okay, so when we are defining the right maintenance practices, how does this fit in? Because we know that there are a lot of sources where spares and services can be taken. But in the gamut of right maintenance practice, how does this all fit in?
Again, a difficult question. I will try. I will attempt to answer that. Look, there is no linkage between whether the spares is sourced from an OEM or the technical manpower is sourced from the OEM will ensure that you are following the right maintenance practices. Yes, normally it happens so because if you are getting the right skill and the right quality of the parts, then it will help you in following the right maintenance practice. But it is not that OEM is a sort of a assurance that you are going to get. You can source the parts from other places also, but how you are going to ascertain that it is exactly the same part which has been fitted on the equipment, or how you can ensure that you are getting the genuine quality, that has to be seen. I will not say it is compulsory that everything has to be sourced from OEM, but I'm saying everything has to be genuine. The problem starts happening when people start making compromises and start using will fit parts. Now there is a difference between a genuine part and a will fit part. A will fit part can get fitted. It may do certain same activity for a certain time period, but ultimately it will not perform as good as genuine, and it will result in a failure. The same goes where how you will ensure that the guy who is providing me service support or technical support, he has the right skill set. He may be from OEM or he may not be from OEM, but the important thing is whether he has the right skill set. If anyway, if you can certify that or ascertain that, you can source from anywhere.
Right. I think that's very comprehensively and very rightly answered. I think we can take couple of more questions. So this question is regarding transmission and engine. So the question is that what is the life that we get once the transmission is overhauled? What is the life we get after overhauling of transmission? That's a very specific question which has been posted.
So I don't have the exact information which transmission we are talking about, because there are multiple transmissions which are being used in material handling equipment, whether it is hydrostatics, automatic, fluid coupling. So there are multiple type of transmission are used, and I think we need to have further information on that, that in what application that equipment is being used, and then only I will be able to answer that what is the life of overall subassembly or a transmission you are expecting in that application.
Okay. And we have a similar specific question. Similarly, how long is the life of the engine?
So ideally, engine should last for somewhere around 10,000 to 12,000 hours. If it is maintained well, it can go up to 20,000 hours, because the life of the engine will depends how you are utilizing it, how you are maintaining it, and how many times you are going to overhaul it. Because any engine at the max can be overhauled twice or thrice. Post that, it is not economically, it does not make economic sense to repair it, but it is better to replace the engine. So it all depends upon what is the maintenance interval of those overhauls which have been performed on the equipment and how you have done that. But it cannot be, any engine should not be modified or overhauled more than 3 times as a general practice.
Okay, okay. I think the next question which is coming in, I will just read it out that it was mentioned about safety in the context of creating zoning for material handling systems. Can you throw some light on collision avoidance in the shop floor due to equipment like forklift? So this is mainly about anti-collision system, if I understand the question correctly.
Yeah, it is very difficult to provide anti-collision devices on a material handling equipment, because they are expected to work in a very narrow spaces, and always there will be places where they are expect to come close to some device or person, and they are expected to perform certain tasks in that constraint this thing. So anti-collision devices are not very popular, I will say, with the metal learning equipment. But yes, there are devices which provides some sort of alarms or audio visual signals to the operator if any obstacle or person has reached to that no movement zone. So I will not say it is a foolproof system, but definitely, because any device has a sensing distance, and when it is having that sensing distance, it will start getting the signal and it will start applying brake. But it all depends at what speed you are operating, whether you will be able to stop your equipment before the collision or not.
Right.
I
Right. So
I think it is difficult to answer technically, but there are some certain challenges. Yes, ideally people want a foolproof system, but audio visual alarms and signals are very much possible where the anybody is obstructing in the zones.
right. I think we have already reached the time. I will take just one last question, and after that we'll close this session. Are there any specific predictive maintenance parameters which can be tracked for diesel forklifts? Any specific for predictive maintenance of diesel forklifts?
There are parameters, like there are pressure readings, and if the pressure readings of a engine oil pressure or a transmission oil pressure goes beyond a permissible limit, you have to understand and try to find out the cause of that. There are places where if you are getting the information about the temperature curves of your engine oil and transmission oil, it can help you in predicting the type of wear and tear which has happened to those sub-assemblies, and ultimately it will result in a timely proactive maintenance. Like if
Right.
there is a pressure drop in this thing, or cooling system is not functioning, so it can predict if the temperature is suddenly not or is increasing beyond a permissible limit. That means either there is some problem with the water pump, or there is some problem with the belt which is driving the water pump. But it is definitely, there are multiple parameters are there which can give you the predictive maintenance capability on a diesel forklift.
Right. So with that, we are at the end of our time limit. So we have to now close the session. Any further questions, we'll get back to the individual respondents, whosoever have put their name and company. We'll get back to them over email. So before we close, once again, we request all the attendees to please fill in the feedback form. It is very important for us to understand your expectations out of this program and any future topics that you would like us to cover. So finally, thank you so much, Manish. I think this was one of the most insightful and one of the most participative sessions that we have had. Uh, we will look forward to having you like more often, because there will be many topics that people would like you to get deeper into, especially after they have understood the right maintenance practices in today's session. So with that, thank you everyone for attending today's session. Thank you for your time. And we look forward to coming back to you with another topic next month. Thank you very much. Bye.
Thank you all for your patient listening and your queries and participations. Thanks. Thank you, Abhishek. So can we close?
Yes.
Okay.